Okay, hello. I hope you're well. Once again. All right, hello, grade 9s, grade 9s, grade 9s, grade 9s. I hope you're well. So we are picking this lesson up from number 33. The question is, what is the rule for the flow diagram? A, y is equal to x minus 1. B is equal to y is negative x minus 1. C is equal to y is equal to 2x minus 4. Or y is equal to negative 2x minus 4. So we are given the input and the output values, so it becomes very easy and very straightforward for us to get the answer, because we are told what the x values are, right? So from yesterday, we did say that we could substitute the input and output values and then check which rule actually works. This is grade 9, grade 9, grade 9, grade 9. So what is the rule for the flow diagram? So I'll take the x values that I have here and substitute and check which rule works. So y is equal to x minus 1. Let's check. When I substitute x, which is negative 1, do I get the output value, which is negative 2? Let's check that out. Yes, the input is negative 1, the output is negative 2. Let's check. When I substitute 0, I get negative 1. So immediately, I'm not even going to go any further. The rule y is equal to x minus 1 is not going to work. So that means A is out. Let's go to B. Let's check B out. Y is equal to negative x minus 1. Let's check. When we substitute negative 1, do we get that output value, which is negative 2? So we have minus 1, minus 1. So a negative times a negative, guys, gives us a positive. So we have 1 minus 1, and that 1 minus 1 gives us 0. So immediately when I substitute my first value, negative 1, into this rule, I do not get the output, which is negative 2. So that means B is also out. Let's go to C. Let's go and substitute y in y is equal to 2x minus 4. Let us substitute the input negative 1 and see what do we get. 2 into C, what do we get? 2 into negative 1 minus 4. So a positive times a negative gives 2 times 1 is 2. Minus 4. Guys, immediately you can see here we have a problem. We have a huge problem because y is equal to negative 6. So when I substitute negative 1 into the rule, I get an output of negative 6. I'm waiting to get negative, but I'm getting negative 6. So that means C is also out. B is the only rule that I have left. So let's check it out and let's check all the values. So if I take my x, which is negative 1, I substitute into the rule. A negative times a negative gives me a positive 2. 2 minus 4 gives you negative 2. Okay, the output, when x is negative 1, the output is negative 2. It works. Let's check the next value. Let's substitute 0. Y is equal to negative 2 into 0 minus 4. If we substitute that, we get negative 2 times 0 is 0. 0 minus 4 gives you negative 4. Okay, it also works. When I substitute 0, I get my output, which is negative 4. Let's check the last value. When I substitute positive 1 into the same rule, D, y is equal to negative 2 into 1. What's negative 2 times 1? It's negative 2. Minus 4. Negative 2 minus 4 gives me a nice value of negative 6. Guys, this works very well. When I substitute negative 1, I got negative 2. My flow diagram says it as such. When I substituted 0, I got negative 4. It works. When I substitute positive 1, I got negative 6. It works. So therefore, we can conclude that y is equal to negative 2x minus 4 is the rule, and therefore my option that I should choose is D. Okay? So this is one way of working out the rule that is attached to this particular flow diagram. I could substitute the input and the output in each rule and check, substitute the input, do I get the output? Substitute the input, do I get the output? So A didn't work, B didn't work, C didn't work, only D works for all values of the input to get the output. So D is our answer. Okay, let's move on, guys, to the next question. Let's move on to the what? To the next question. Okay, question 34. Question 34, you can see there, we have 3y is equal to negative x minus 3. And the flow diagram, the table, and a straight line are there, with also an equation is there. Now we are being asked, which of the following representations is true for the given function? I repeat, which of the following representations is true for the given function? So you have 3y is equal to negative x minus 3. Which of the following representations is true for the given function? Is it A, y is equal to 1 over 3x minus 1? Now, let us check if A works. Let's take the given equation, which is 3y is equal to negative x minus 3. To check if A is the one that works, let's take this equation that is given to us and write it in the standard linear form. What do we mean by the standard linear form? Let us isolate y and check if it will give us something similar to what we have in A. So what do? We write 3y, then the coefficient of y is 3. So we are going to divide the term 3y by its coefficient, which is 3. But what you do on the left, you are going to do on the right for each term on the left hand side. There are two terms on the right hand side. So you are also going to divide them by this coefficient, which is 3. 3 divided by 3 is 1, so we are left with y is equal to, then we have a negative x over 3 minus 3 divided by 3 is negative 1, because this is a negative and a positive, which gives us negative 1. So we have a negative 1 over 3x minus 1, which is the equation of the linear function when we write the equation of the linear function in its standard form. Now, if we look at this form, does it represent what you see in A? Y is equal to 1 over 3x minus 1? No, it doesn't, because this one has a negative. A has a positive 1 over 3. So A is not the answer. A is not the representation of this linear function. Let's move on. Let's go to number B. Is B, the table, a representation of the function? So what we can do there is we can take the function that we now have, which is y is equal to negative 1 over 3x minus 1. We are told that x is equal to negative 3. The output should be 0. So let's check if we substitute negative 3. Will we get an output which is 0? So what's negative times a negative? It's positive. What's 1 over 3 times 3? It is positive 1. What's 1 minus 1? That gives you 0. So in your table, when you substitute negative 3, yes, in the table, our y value is 0. So it works for negative 3. Let's check if we substitute the negative 2 do we also get half, which you see as your answer there? Let's check this one. If I substitute negative 2, negative times the negative is positive. 1 over 3 times 2 is 2 over 3 minus what? Minus 1. Then you could take your calculator and punch in 2 over 3 minus 1 and check what do you get as your answer, which is a fraction. You should get negative 1 over 3, which is the y value that comes when you substitute negative 2. So if the answer is not half, which is the output that you see in B when you substitute negative 2, then that means the table is not a representation of 3y is equal to negative x minus 3. Sorry about that, guys. So that means the table is not it. Because what were we expecting when you substitute negative 2? We were expecting here to get half, but we are getting negative 1 over 3. So that means that the table is not a representation of 3y is equal to negative x minus 3. So now we need to go then to C, which is the flow diagram. Guys, in the flow diagram, okay, we're getting negative 3, and you can see the rule there says y is equal to negative 1 over 3 x minus 1. Now you should see very quickly that, oh, we did work the function 3y is equal to negative x minus 3. We made y the subject, we isolated y, we divided by 3, all 3 terms. Then we got negative x over 3 minus 1, which gives us negative 1 over 3x minus 1. So this here is a representation of this function. We get negative 1 over 3x minus 1. If you go to number C, or letter C, you can see your rule. It resembles what you have here. Negative 1 over 3x minus 1. You see? Do you see that, guys? Then let's check. When we substitute the first input value, which is negative 3, do we get negative 2? When we substitute the first input value, negative 3, do we get the output, which is negative 2? And guys, you can see that when we substitute negative 3, we get an output of 0. Whereas in your flow diagram, you get an output which is negative 2. So immediately that says that C, the flow diagram, is not going to cut it. So C is out. It's not the flow diagram that is a representation. Okay? I mean, we could even finish it off by substituting the last input value, which is negative 1. Let's see, if we substitute y is equal to negative 1 and check what do we get as an output. We get 1 over 3 minus 1 will give you negative 2 over 3. You can check with your calculator. Okay, so the honest reality, if you go look at the flow diagram, you would think that the flow diagram is the one, because 1, the rule resembles what you get when you make y the subject. That's the first thing. 2, so the rule is there. I can see it in the table, I mean in the flow diagram, in my rule. 2, when I substitute negative 3, the only problem is that when I substitute negative 3 in the rule, and negative times a negative is a positive, 1 over 3 times 3 gives me 1. 1 minus 1 is 0. I don't get the output, which is what? Which is negative 2, that I'm expecting to get as I see in the flow diagram. So that means that this rule or that flow diagram is not a representation of this function. It's not. So we've ruled out A. It's not A. We've also ruled out B. B, the table does not work. Now let's look at the function itself, the graph. Okay, I have a graph here. I can see the x-axis, the x-intercept, okay, is -3. Okay, the x-intercept. So the coordinates there are -3 and 0. Then with the y-intercept, I can see I have 0 and -1. The graph cuts the x-axis at -3. If you look at D, the graph cuts the x-axis at -3. The coordinates that represent that -3 are -3 and 0, as you see there in my coordinates. The x-intercept, when x is -3, y on the x-axis is 0. Then the graph also cuts, the line cuts the Cartesian plane at -1, where y is -1. So the coordinates there on the y-axis, x is 0, y is -1. So all we need to then do, and secondly, what you do notice is that the straight line is actually a decreasing straight line. It's a decreasing straight line, so that means that the gradient is less than 0. Okay. Now, I was able to write that straight line function 3y is equal to -x minus 3. I was able to write it in standard form by isolating y. So I have y is equal to -1 over 3x minus 1. So I'm going to check now these three things, if they are actually working to get my equation of the straight line, which is this one. So let us use our approach that we know we ought to use when we want to find the equation of a straight line. So firstly, let us find the gradient by saying m is equal to y2 minus y1 over x2 minus x1. Okay. And remember, I got this coordinate, -3 and 0, from the line itself. The graph cuts the x-axis at -3. So the coordinates, when the graph cuts the x-axis at -3, y is 0 on the x-axis, x is -3. The graph then cuts the y-axis at -1. That's the y-intercept. So that means there on the y-axis, x is 0, whereas y is -1. So now I can use the gradient formula and find the gradient of the straight line. Okay, and what am I expecting to get? I'm expecting to get this equation. If I get this equation, then it means that that graph represents this straight line function as you see it. So let's go and find the gradient. Remember, my first pair of coordinates, I'm going to say this is my first pair, -3 and 0. So I'm going to say this is x1, y1, and I'm going to say this is x2, y2. Then I'm going to substitute in the formula y2 -1. The formula has a negative sign, so I write the negative sign. y1 is 0 over x2 is 0. The formula has a negative sign. I write that negative sign followed by -3. So in brackets, I write -3. Okay. So far, I hope we are moving together. So far, I hope we are good. Okay, then to calculate the gradient, -1 minus 0 gives you -1. 0 minus -3 is actually 0 plus 3, because a negative times a negative is a positive. And then that's -1 over, what's 0 plus 3? It gives us 3. So our gradient is -1 over 3, and it resembles exactly the gradient of the function that we basically expected to get. So far, I think we are good. Now we can write the equation in standard form. And remember, what is this? C. C is the y-intercept. This is the y-intercept. And remember, guys, y-intercept is where the graph cuts the y-axis. So if we go to our function, where does the graph cut the y-axis? It cuts it where y is equal to -1. So then we can go to the c value and substitute in the place of c C is equal to negative 1 because the y-intercept is negative 1, so that it means our C value is going to be negative 1. So we can see that y is equal to negative 1 over 3x minus 1 when we find the equation of the function using the x-intercept, y-intercept. Find the gradient of the straight line, which is negative 1 over 3 as we found it, and then write the equation in standard form where the y-intercept, which we know is negative 1, we write the y-intercept in the place of C, and this is our equation. Does this resemble that? Definitely. So that means D is our answer. Letter D is definitely our answer. That graph which is in D is what definitely represents 3y is equal to negative x minus 3. Okay, guys, I hope you are seeing that this GEC thing, the multiple choice, really needs you to do some rough work on the side before you select a answer of your choice. You can't just play guessing game here. You can't. Agiri, you want to get all the marks, right? You have no other intention. You want to get all the marks. So in order to do that convincingly, you need to then make sure, that you are doing what needs to be done. Okay. All right. I don't know if we have any questions, but I hope it's clear and we are good. Okay. Let's move on to number 35. Grade 9. Question number 35, we have a table there. We have x values, 1, 2, 3, 7, and then z. And then we have y values, 3, 6, 11. 3, 6, 11. Okay, 3, 6, 11. And then you have your x value, which is 7. Output is 51. And then you have z, and then your output, which is 258. So then the question there is asking, what is the value of x, the input? Value of z, the input. Okay. And 35 says, what is the value of z? Is it A, 64, B, 32, C, is it 16, or D, is it 8? So any ideas, guys, as to what we need to do here for this particular question? Any idea at all? Anyone who wants to tell us what needs to be done here? So any thoughts, guys? What is the value of z? What is the value of z? Is it A, 64? Any thoughts? Any thoughts at all? Right, so guys, let's just let's check it out then. So this is a typical example of, if you look at your output values, your Y values, I just want you to check what's happening with the output values. You have 3, okay, you have 6, you have 11 for your first 3 numbers. Then your 7th value is 51 and your Z value is 258. Okay, so there we have it. First value is 3, second value is 6, third value is 11, but then your 7th value is 51. Your Z value, which is what you're looking for, that's what you want to look for. Okay, so there's something you should then notice here, that your difference between 6 and 3 is actually 3. Your difference between 11 and 6 is 5. So it seems like there is a pattern here, okay, a very visible pattern. Let's just check here. Okay, so 3 plus 3 is 6, 6 plus 5 is 11. You see what's happening here? Then if we look at the 4th, 5th and 6th term, okay, we know that the 7th is 51, but it would mean that if we are going in the same pattern, that would mean this is 3, 5. We're expecting that it's 3, 5, 7. We are going up in 2s. So 11 plus 7 is going to give us a term of the 4th, which is 18. 9. 18 plus 9 is going to be what? We're expecting 27. 27, so that's 4th, that's 5th. 27 plus 7, 9, 11. 27 plus 11, you're expecting 38. And then you're going to say 38 plus 13, you're expecting what? 51. So do you see, guys, that your first is 3, second is 6, third is 11, fourth is 18, right? And what you are noticing here is that 3 plus 3 gives you 6, 6 plus 5 is 11, 11 plus 7 is 18, 18 plus 9 is 27, 27 plus 11 is 38, and then 38 plus 13 gives us that 51. So you see, we've really arrived at that point. You see, so it really makes sense. It really absolutely makes sense. Now, we have a term at some point which is going to give us 258, and what we want to know is what is its what? Position. Okay? What is that term's position? Okay? Because we know 51 is the 7th term. Okay? And so what we notice here is that this first difference gives us a constant difference of 2, 2, 2. So as grade 9 learners, we can see that this sequence, my first difference, gives me a constant difference. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So it will be 2, 2, 2 all the way. Okay. And so to try and spend time now trying to add. I can do that manually until I get what is the position of the term that will give me 258. Or I can make things very easy. I can find the general term of the sequence, okay, which is linear. So I know Tn is equal to 2n plus what? Your Tn is equal to dn plus c. This d is the constant difference of the sequence. So I know that this is going to be 2n. And then I'm going to find the general term of the sequence. Okay? The general term of the what? Of the sequence. So that means if I want to find the general term of the sequence, then I can basically take c is equal to t1 minus t. Remember, term 1 is 3. So I can say 3 minus d, which is the constant difference of 2. And 3 minus 2 is 1. So tn is actually 2n plus 1. Then what I can do is I can say Tn is equal to what? 258. Which means in the place of Tn, I'm going to write 258 and solve for n so that I can find out what is the position of this term in the sequence. Okay? So this one is T1, this one is T2, this one is T3, and so it goes. So I want to find out what is the position of the term in this particular sequence. So I'm going to say Tn is equal to 258, Tn is 2n plus 1 is equal to 258. Let's now solve for n. And then I can't really do that. Sorry guys, my mistake, my biggest mistake. I can't really do that because 3, 6, 11, sorry, this is for the original. Okay, so I think we're going to have to do it manually. Okay, so let's do this. 51. Now we know after that we have 15. 51 plus 15, that will give us 66. 17, 66 plus 17, that will give me 93. No, sorry, 83. Plus 19, 83 plus 19. I think guys, you can definitely use your calculator to just fast check the process. 89 plus 83 plus 19. You get your original term, which is what? Oh, by the way, so this is my 7, this is 8, this is 9, 10. Okay, so 83 plus 19 gives me what, guys? 83 plus 19 gives me 102. I know this is long, but okay, then 102 plus 21. 123, 21, 19, 21, 23, 146, 25. Okay. 171. 27, 198, 29, 198 plus 29, 198 plus 29, guys, 17, 9 plus 2 is 11, 12, that's 227, that is my 15th term. 31, 258, my 16th term. So Z, guys, is equal to 16. C is my answer. C is my answer. Okay, so you see, we did it manually, and ultimately we were able to find the position of 258. It is the 16th value in the sequence. Okay, so that was quite long, right? It was very long. But then at the end of the day, we were able to get the answer. The answer is not going to be A, it's not 64, it's not B, it's not 632, it's not C, 16, it's not D. I mean, it's C, sorry, it's 16. It's not D, but it's Z is equal to 16. Okay? Yeah, okay. Let's move right along to the next question. The question here says, which graph represents the line that is represented in the table above? Which graph represents the line that is represented in the table above? Now I'm expecting you guys to actually look at the table. The table has x values -2, -1, 0, 1, and 2. So your x values come from the negative side all the way to the positive side. But look at your y values. Your y values are the same. In other words, your y values are constant. So if you were drawing a straight line of this type of function, would it look like A, a straight line that is cutting the y-axis where y is positive, or B, a straight line that is cutting the y-axis horizontally where y is negative? Would it be C, a vertical straight line that cuts the x-axis where x is positive, or D, a vertical straight line that cuts the x-axis where x is negative? So which representation of the straight line would you say is represented in the table? Indipile Nyane says it's A. Do we all agree with Indipile, or do we have a different answer? Thank you, Indipile, for that answer. Indipile is saying A. And I just want to go and check if A is really what the answer should be. Guys, when you have a Cartesian plane, right, these are your x values, -2, -1, 0, 1, and 2. Now they are saying for every x value -2, the y value is 4. So this is where -2 and 4 would be. Where x is -2, where y is +4. Where x is -1, where y is +4. Where x is 0, y is 4. Where x is 1, y is 4. Where x is 2, y is 4. If you connect the dots, you have a horizontal straight line. So if we look at the answer that Indipile gave us, Indipile is 100% correct. Okay, so any situation where the x values change but the y values are constant, that is a representation of a horizontal straight line. Okay, and this is what you would basically expect to get for your graph. So Chire together with Indipile, 100% spot on. Okay, let's move on to the next question. So it can't be B, because y doesn't cut the y-axis where y is negative. It can't be C. Remember, if it is C, then who is constant? Who is the same? It is the x value. And in this table, x is not the same. D, It can't be that vertical line as well. 37. 37 is saying, grade 9s, which of the following ordered pairs represents the graph? Which of the following ordered pairs represents the graph? So let's make this a little bit bigger. So I'm sure you can see, right, the graph where x is -4. Okay, from our table, guys, we have x starting from where x is -2. That's what we have from our table up until where x is +2. Okay, so what we want to do as we look at the graph, we want to check which graph actually represents, as closely as we can see, what we see in the table. So if we look at the graph, for instance, where x is -2, right, it seems like our y value is between 1 and 2. I repeat, where x is -2, it seems like our y value is between 1 and what? And 2. So if you go and check your y value for a, you have 20/3, which is a positive value. But what is 20 divided by 3, guys? What do you get in your calculator? When you divide 20, say 20 divided by 3, do you get a y value that is between 1 and 2? Please check that for me, guys. When you substitute, when you divide 20 divided by 3, do you get a y value that is between 1 and 2? Is 20 divided by 3 a y value that is between 1 and 2? Because we know that our y value should be positive. When x is -2, the y value should be positive. So straight up, we know that b, we are going to cancel b. The table b cannot work because that table says when x is -2, y is -20/3. We know that the y value is not negative. The y value is positive. From the graph, we can see that when x is -2, the y value should be a positive y value, not a negative y value. So B and D, we're going to eliminate immediately. We're not even going to waste our time and look at B and D, because B gives us -20/3. Can't be a negative value. D gives us, when we substitute -2, the y value is -104/3. So B and D are out. So the only options I'm looking at now are A and C. You see how I made life easy for myself? Because I know my stuff. So Lu says when you divide 20 with 3, you get 6,666. Now, I said to you guys that when x is -2, our y value, according to the graph, is actually a y value that is between 1 and 2. 6,666 is not a y value between 1 and 2. Okay? So I hope that makes sense. Ndumiso, you can go to my bio, the link in my bio, the YouTube link in my bio. Click on the link, subscribe to my YouTube channel. I will upload this live session onto the YouTube channel, as I've uploaded all the other grade 9 live sessions that I do in the morning. They are already there. Then you can actually rewatch the video in your own time. Okay, and you can also catch up from the questions that I've done, question 1 from the beginning. The videos are there on my YouTube channel. You can rewatch the live lessons, okay? Unfortunately, I don't go live after school, okay? Unfortunately, I always go live in the morning for grade 9s, okay? Anyways, so B, guys, is out as well. B and D, as well as A, are out. Alu is saying it seems like it's the 4/3 that's between 1 and 2. Yes, Alu, I seem to agree as well, okay? But it seems like it's only what? It's only C that is between 1 and 2. 4/3 is a value that is between 1 and 2, because we get 1,3. Okay, so that means C will work. Okay, If you look at negative 1, you substitute. If you look at C as well, when x is negative 1, y is 8 over 3. So if we look at the straight line itself, when x is negative 1, what we are seeing is a possible value that's between 3 and 4. Okay, that's between 3 and 4. When x is negative 1, our y value, in fact, sorry, our y value is slightly below 3. Slightly below 3. When x is negative 1. When x is negative 1.